Hello everyone, my name is Weiji, and I'm a PhD student from Victoria University of Wellington's Antarctic Research Center. Today I'm going to give a quick overview of the solution I'm presenting to solve crevasse navigation in Antarctica using an end-to-end integrated deep neural network. So let's get started. Say you have this satellite image, or any image really, may be taken from a drone flying above you. In Antarctica, well, it might just look really white. But actually you want to know if there's crevasses you might fall into. You might not see it, but maybe an expert can. And it turns out there's a team of scientists who have done it using MODIS satellite data collected on the Ronny ice shelf. So let's try to leverage off that. So let's take the fracture lines they've digitized and use it to train this thing called a convolutional neural network. What this thing does is it passes the image and the training lines through a series of filters that detects edges, contrast differences, etc. And you'll produce a prediction of what it thinks are crevasses. At first it might not do a good job at finding crevasses, like this one might be wrong here. By using supervised learning, it will learn from its errors via backpropagation, and eventually, after a good amount of trying, the model will produce a good result. Next, we'll take this crevasse map, I'll zoom it out here, and we'll give it to a neural network agent who was simply thrown into this dangerous crevasse-laden environment. We'll start it off randomly somewhere on the map and try to teach it to reach a goal somewhere else. The way we teach it is using something called reinforcement learning. Basically, if it reaches the goal, we'll give it a +1. If it falls into a crevasse though, we'll do -1. The agent learns to navigate by maximizing its reward. We'll actually start things in easy mode by placing the goal close to it, so it has an idea of what earning the goal is like. As training progresses, we'll place the goal further and further away through a technique called curriculum learning, much like what school kids go through. The exact method we'll use to train this is something called an asynchronous advantage actor-critic network, or A3C for short, born out of Google's DeepMind company. Basically, it's just one of the fastest ways you can train this sort of neural network. Finally, we'll join these two things together. On the left, we have a crevasse classifier which produces, well, a crevasse map. And on the right, we'll have our navigator agent, which outputs action quality values, or Q values, on what is a good move to take right now. It's actually quite cool how this integration is seamless. The model is now effectively a single deep feed-forward neural network. We just have to train the two parts separately. Running it is also so much simpler. You feed it your input image here, and well, also where you want to go. And off the network goes, doing all the fancy mathematical calculations for you. Well, thank you for watching this quick overview of my crevasse navigation solution. Please do check out the GitHub page for this New Zealand Space Challenge project I've linked to in the description below. There you'll find all the nice Jupyter notebooks that goes into the nitty-gritty technical details. Have fun!